Welcome back. We're in chapter 14 on acids and bases, and we've reached 14.8 section on acid-base titration. Acid-base titration is a lab that is very useful in order to find a molarity or a concentration of either an acid or a base that you do not know based on a known acid or base that neutralizes it. So if I have an acid that I don't know what the molarity is, one way that I can determine the concentration, like remember I've said in the past, you can measure a concentration of something. Well, how do you actually do that? One way of measuring the concentration of an acid is to find out how much base neutralizes that acid. And if I know the volume of the base and I know the molarity of the base, I can use its balanced equation to find out exactly what the concentration of the acid is. So this is called titration. And it's not really a hard concept, and it's actually a little bit fun. A lot of people kind of like this. So let me try to explain it to you. What you have is you have an acid of an unknown molarity. So I don't know its concentration. I know that I've got some acid dissolved in water, but I don't know how concentrated it is. So what I'm going to do is I'm going to take a base and I'm going to put it in a burette and I'm going to put in a certain amount so I know exactly how much of a volume that I have and I know its molarity. Okay, so I have both its molarity and its volume. I know how much I have here, so I have its volume, but I do not have its molarity. If I can somehow know when all of the acid has been neutralized, then I know exactly how much base it took to neutralize it. Then I can go through the balanced equation with a simple stoichiometry idea and find out what the amount of molarity or what the molarity of the acid is. It's just a way to find out the concentration. So let me try to explain it. I need to know when all of the acid is gone. Okay, I need to know when the pH is exactly 7. And there are some indicators that will do that. So if I can put, for instance, if I can put a certain indicator in, which is usually some kind of an organic dye, at a certain pH, it'll change color. It'll be one color when it's an acid. It'll be another color when it's neutral. Or it may be invisible and then show up as a color at a certain pH. Okay, so normally we use phenolphthalein, which will turn pink at exactly 7, which is really good. Because if I have a very strong acid, like hydrochloric acid, and I have a very strong base, like sodium hydroxide, each hydrogen will combine with a hydroxide to form water, and that water is a pH of 7. So when all the acid's gone, the pH should be 7. So if I have an indicator that will turn a different color exactly at 7, then I know that all of my acid is used up. Then I can measure the base that I used and figure out the molarity of the acid that I don't know. So at the end point, when all of the acid is turned into water, when all of the acid and the base have combined and made water at the end, you're going to get a permanent color change. So it'll turn a very pale shade of pink. If you get a very dark shade of pink, you've actually put too much base in and you've gone the other way. But if you can be very, very careful so that you're waiting for the one drop to turn it a solid color of pink, then you know that you are exactly at 7. And if you're exactly at 7, now you know how much base you used at the molarity, and you can go through the balanced equation to figure out what the molarity is of the unknown acid. So you're going to state the given and needed quantities, and then write a plan down based on the balanced equation, and then put in what you know and find out what you need to know. Here's an example. What's the molarity of 10 mils of a hydrochloric acid solution? So I don't know its molarity, but I know that there's 10 mils of it. If 18.5 mils of 0.225 molar hydrochloric or sodium hydroxide are required to neutralize it. Okay, so I've got a molarity and I've got a volume of sodium hydroxide, and I'm asked to find the molarity of this other hydrochloric acid if it neutralizes it at that amount. Okay, so you're going to go from the neutralization equation. Here's the neutralization equation. You have an acid, which is aqueous. You have a base. This is a strong acid and strong base. And you're going to end up with a salt and water. You're always going to do that. It's always going to be a salt and water. So if I know the molarity of this, then I can find out how many grams of this there are. Okay, I can go through the periodic table and say that in a certain amount of liters, I've got a certain amount of grams. That means I can go back here and find out how many moles are coming in, how many moles are going out, turn it into grams, and then however many moles over liters here is the molarity of the acid. Okay, so I want to know what is the amount of moles in the amount of liters. So if it's 0.225 molar, then I know that there's 0.225 moles in 1 liter of sodium hydroxide. Then I'm going to find out how many liters that I had here. Okay, they gave me 10 milliliters. Well, how many liters is that of HCl? And now the moles will be equal because this is 1 to 1. It'll be equal, and then I'll be able to find it. Okay, so what I've got is I've got that there are 0.225 moles in every liter. Okay, and then you'll end up with 1 mole of hydrochloric acid. And when you divide by the amount of liters that you have, which is 0.01 liters, you'll end up with 0.416 molar hydrochloric acid. We'll do all these examples in class, but this is just kind of a way to show you what we're doing. That's it. That's all it is. So I will see you in class.